Well, previously we have seen the implementation of trees. Basically, in trees, every node may have any number of children. That means there is no restriction on the number of children per node. But in case of binary tree, there is a restriction that any node in the tree can have at most two children. That means a node may have zero children, that means no children, or a node may have one children or maybe two children. So that means at most two children. This is what the condition on the binary tree. So that is the reason the previous code that what we have developed, that is a trees code, in which we have written this struct node star star next. So here we have created an array for the holding the address of the children. But this particular array is not required because we need to have maximum two children per node. So that is the reason what we can do is simply we'll copy this and just we'll make some modifications in this. So this I'm saving it as a binary tree. So in this, since every node may have only two children, so children count is not required. And here node star star next instead of next. So children is at which is at the right side, and a node which is at the left side of the uh, parent. So two children. If a node don't have any children, then the right value will become null and left pointer will also become null. So this is the way how the binary tree can be modified, can be written. This is the program to demonstrate binary tree. So here what I'm doing is, for example, 110 is the root, which consisting of children like 1 and 2. So you may use 1 and 2. And 2 may have further children. 2 may have further children like 4 and 5. So like this, a binary tree represents. So this 10 is a node which consisting of two children, 1 and 2, and 2 is a node consisting of two children, 4 and 5. And if you observe 1, it is itself is a leaf node and it don't have any children. This is the way a binary tree can be constructed. So once we return the node structure, so obviously we need to have node root is equal to null. As usual, like in the previous code, int e is empty. This is especially to create a is empty to check whether the node is root is empty or not, or tree is empty or not. Struct node star create node of int. This is especially for the creation of node. Void insert of struct node star comma int. So while insertion we require double pointer because one pointer is for the taking of the address and traversing, another is to create the memory. So that will define the is empty, int is empty. So when can you say that a tree is empty? Return if root is equal to null, then 1 else empty. Next, struct node star create node value. So as usual, we'll create a struct node star temp is equal to null. If root equal to null, or we can say temp is equal to struct node star. Here we are going to use malloc of size of struct node. So temp data is equal to value, temp left is equal to null, temp right is equal to null, return temp. So this is the way node creation, that is memory will be allocated for the node. So along with the create node, we need to have another helper function, print tree. Whenever you pass the root address, automatically to print tree. This also will define void as usual create a temporary pointer. Temp temp null, yeah. Then print tree of temp tree of temp right. Basically, this is to have in order traversal like this. First you print the left subtree, then the parent, the right side. Then print it. So this is the in order travel. How we can do this. Next, we need to create a tree like this: 10, 1, 2, 4, 5. So first we will create a root node for main method. So root equals null, root is of 10. Now the root node 10 is going to be created. Now 10 left must be 1 and 10 right must be root left equal to 1, root right of 2. Now root Next, root right side left value is 4. Root right side's right value is 5. What I can do is root left right side equal to 8. So what is the root right left side? 4. 4 root right side here of, so I can print 3 root. So that first left side values 1, next 10, 4, 2, 5. This is the order of print. 1, 10, 4, 2, 5. You can print the first left side values, next parent, next right value. Now we'll see the output of this code. So 1, 10, 4, 2, 5. The output that what we have expected, because 1 is the leftmost child of root 10 and 4 is the leftmost child of node 2 and 5 is the right child of node 2. So 1, 10, 4, 2, 5. This is the output what we get. Now what we can do is, I hope you must have understand coding. One thing you can do is, you may add here in the insert, you may add here character. That means you may take the character as either two characters, that is either L or R. That means if the character is L, then the node that what you want to insert will be inserted at the left side of the parent node, and R means the value will be inserted at the right side of the parent node. So for this, what I can do is int, and from this is for the parent value, this is for the child value. So this is for the insertion. So here I can insert 2. So this function need to be defined like void insert 2 of star node parent value field value character side. So at which side you want to insert? Then you define, because what you're supposed to do is, first of all you have to check the root value. The root is not null, then you use iteration for, you may use recursion for checking the parent value. You found the parent value for a particular in the particular tree, then check for the child value and insert at the particular right to the right side or left side. Create a node with the child value and insert at the left side or right side based upon the character side that you have used. So this is the task. You can do it. I think so. You may complete this particular task. This is the way how the binary tree can be constructed. And deleting of the binary tree, there exist three main things that we are supposed to do. If it is a leaf node, directly you can delete it. If it is a parent node with one or two child, then these childs must be given to the other parent, which is of the topmost parent of the current parent. So if it is having two children, then how to delete? If a node is having only one children, how to delete? If a node doesn't have any children, then that particular node can be directly deleted. That is not a big task. So these are the three cases need to be considered while deleting a node from the binary tree. But binary trees are, for example purpose, I have typed this code and I have shown you. This can be further improved in any way, in many ways. So for time being, what you do is so you insert the element into the binary tree based upon the side that was next. The next video is the binary search tree implementation. That is